I'm not going to do all problems anymore. I'm selecting 6, 8, and 10. That's what I'll do right now. And those three should be enough to serve as sort of a model guide for you guys to do. Attached on the class website is this handout, and way at the end you will see the answers. So the answers are attached to this. Number 6, my y is already isolated, and it equals to 5x minus 7, so that makes my life very much easier. So I'm going to substitute. I get 5x minus 7 equals negative 12. Negative 3x minus 10x plus 14 equals negative 12. I can combine like terms here, and I get negative 13x plus 14 equals negative 12. If I subtract negative 14 from both sides, I'm going to get negative 13x equals negative 26. I divide both sides by negative 13. X is going to be positive 2. Now I can take that, I can take that and go back here to my first equation, right? And I can write 5 times 2 because I know what x is now, minus 7. Y equals 5 times 2, which is 10 minus 7, and y equals 3. So, like I said before, the point of intersection of these two lines would be here, and that solution also would make both equations true. So if I do my check, I take my first equation, and I substitute 2 and 3, so y is 3, 5 times 2 minus 7, 3 equals 10 minus 7, and you can tell 3 equals 3, so the first equation is done. Second equation, negative 3 times 2 minus 2 times y, which is 3, that should all give me negative 12. That's negative 6, this is also negative 6, and negative 6 minus negative 6 is negative 12. So you can tell that this value, x equals 2, y equals 3, worked for both equations. Okay. Next one. So really doesn't matter who you isolate. I don't want to isolate this one because the x has a coefficient, the y has a coefficient, so I'm not really going to work with the second one, but I'm going to work with the second equation. So I got x minus 2y equals 11. So what I'm going to do is I'm going to make that look somehow like x equals something. So there are two sides, and on this one I'm going to do plus 2y and then plus 2y. If I do minus 2y plus 2y, this disappears, and look, my variable x is all by itself. So on the other side I have 11 plus 2y. I can't combine those two because they're not like terms, so I have x equals plus 2y. So now this, I'm just going to write it over here. X equals 11 plus 2y. That's the same equation, just written in terms of y. Now, I'm going to use that information, go to this equation, the larger one, and I'm going to substitute wherever I see x with 11 plus 2y. So I'm going to get negative 7, 11 plus 2y, minus 2y equals negative 13. I get negative 77 minus 14y minus 2y equals negative 13. Negative 77, I combine these like terms here, I get negative 16y equals negative 13. Plus 77 on both sides. And these will go out, negative 16y will come down, and this is going to give me, 77, 13, 63. Really 64, sorry. 64 positive, divide by negative 16, divide by negative 16, y equals negative 4. So now I have my value, my y, right? I'm going to go back to one of the equations. I'm going to take the second equation. And x equals 11 plus 2 times negative 4. X equals 11 plus, or minus 8. X equals 3. So my x value is 3, my y value is negative 4. Now that I have these two, I can check. So I'm going to erase a lot of this stuff. Erase, erase, erase. And I check on both equations. I take the first equation, which is negative 7, this one right here. Wherever I see the x, I change it with 3. Wherever I see the y, I change it with negative 4. And so I get negative 7 times 3 minus 2 times negative 4. And that should give me negative 13. Let's see if that's true. Negative 7 3 is 21. Negative times negative is positive. And 2 times 4 is 8. Oh, this is negative 21, by the way. And let's see if that equals negative 13. Negative 21 plus 8 is more negative, so definitely. It worked for the first equation. The second equation, x minus 2y equals 11. So x is 3 minus 2 times negative 4 equals 11. This is and then I get 3, negative 2 and negative 4 is positive 8, sorry, equals 11. And 3 plus 8 is 11, which equals 11. So as you can tell, this value here worked for this equation as well as for that second equation. Number 10. So for number 10, again, I have to pick one of these, right? Because you want to isolate either the y or the x. Pick whichever you think it's easiest. Well, you notice that in the first equation, the y has no coefficient, so that's probably the easiest. So I get negative 5x plus y equals negative 3. So remember, I want to make it look like this, so the y is all by itself. So what I can do, I'm going to add 5x to this side, and I'm going to add 5x to this side. Minus 5x and 5x, that gets rid of the 5x, so you can tell I have my y isolated. On the other side, negative 3 plus 5x, right? So this equation is the same thing rewritten, negative 3 plus 5x. Yeah, erase that. Now, I'm going to go to my second equation. I'm going to use this information. And wherever I see the y, I'm going to replace the y with negative 3 plus 5x. So I'm going to get 3x minus 8 times negative 3 plus 5x, because that's the value of my y, right? So equals 24. 3x plus 24 minus 40x equals 24. Combine my terms. 3x minus 40x is negative 37x, I think. Yep. And then, oops. Plus 24 equals 24. I combine these two, right? Now I'm going to subtract 24 from each side, minus 24 from each side. I get 0, negative 37x, oops, negative 37x, and this also becomes 0. So negative 37x equals 0, divide by negative 37, divide by negative 37. That becomes positive, and we get that x 0 divided by negative 37 is 0. So the x value is 0. Now I need to find my y value, so I'm going to go to this equation. Y equals negative 3 plus 5 times 0. Y equals to simply negative 3, because 5 times 0 is just 0. That's going to be 0. So my value, my x value is 0, and my y value is negative 3. Now I'm going to check. So to check, I go to my first equation. I get negative 5 times 0 plus y, which is negative 3, equals negative 3. Let's see if that's true. I substitute 0 for x and negative 3 for y, right? So negative 5 times 0 is just 0. 0 plus negative 3 is just negative 3. That's definitely negative 3 on the other side, so we're good there. On the second equation, it's 3 times 0 minus 8 times negative 3. Does that equal 24? Well, 3 times 0 is 0, so that's gone. Negative 8 times negative 3 is positive 24, which equals 24 on that side. So I know again, my equation is true. Okay, so those 3 examples pretty much cover all the things. And again, here are the answers. You still need to show work. Okay, that's that.